Pong. The first commercially successful video game, it was released by Atari in 1972 as their debut game and sold more than 35,000 units, which doesn't sound like a lot by today's standards, but the internet, CDs, DVDs didn't exist and the pocket calculator was the newest thing on the market. Hi, my name is Michael. I'm creating a video series where I recreate old arcade games in Unity, while also going over a little bit about how they did it and also showing my thought process when breaking down the features of the game. Pong being one of the first games makes me think that it's a good place to start with this series. So in this video I'm going to be going over how Pong came into existence, and then I'm going to go into detail about what gameplay features are in Pong, then I'm going to be recreating it in Unity. This version that I recreate will be available to download from GitHub in the description below. Finally, I'm going to take that recreation of Pong, make a few modifications to it, and then upload the remixed version up to itch.io, which you can play in the description below. So let's get started with Pong. Allow me to set the scene. Atari has just been formed by two men, Nolan Buswell and Ted Dabney. They created Atari to essentially take game ideas from other companies and then make them. They signed a contract with Bally Manufacturing Company to create a driving game. Nolan then went to an old co-worker he had called Alan Alcorn and hired him onto Atari as a developer. However, Nolan thought that developing a driving game would be too complicated for Alan's first game. Nolan essentially gave Alan a warm-up project, and that warm-up project would end up becoming Pong. Unlike today, where we can use game engines like Unity and Unreal to help with our game development, Pong didn't have a CPU or code to run on. The entire game was built through electronics, gate chips, timers, counter chips, and TTL circuits. After it was finished, Nolan added a coin box, like the ones you would find on a pinball machine, and sent Pong off to market. Fortunately for us, it's the future. We don't have to worry about all the electronics nonsense when developing a game. We have programming, which is much easier. So now we're going to go over a quick breakdown of the features that are in Pong so that we have a list of things to do when we jump into Unity. Pong is pretty simple to break down. There are two paddles on either side of the screen. These paddles can move up and down, but not so far that they are touching the walls. Alan made it like this because when you had two players who were particularly good, they could end up just locking the ball up there and making it bounce back and forth, and the game would just never end. There is a ball that moves back and forth between the paddles and slowly gets faster, and there is a scoreboard that increments every time a paddle misses the ball depending on which side missed the ball. We need to make sure the ball can actually bounce in an upward and downward direction depending on where the paddle hits. And graphics wise, the game is just white blocks, so that's nice and simple. Sound is also pretty simple too. There's only 3 sounds in the game. The sound when the ball hits the top wall or the bottom wall, the sound when the ball hits a paddle, and a sound for when a point is scored. Obviously, 2 players will need to be able to play the game at the same time, taking control of either paddle. But I'm also going to make a single player mode which will have a simple AI that follows a ball and hits it back to the player. We're also going to add a menu so the player can choose whether they want to play 2-player or 1-player mode. So now that we have this list of tasks to complete, let's knock these out and recreate Pong. Okay, so we have a fresh 2D project here in Unity. The first thing we're going to do is we're going to add some 2D sprites. Now we need a sprite for the ball, so we're going to create a sprite 2D square. We're going to make that a bit smaller, and then we have some little sprites for the center. Now we can work on our first script. I'm going to create a C# script, and it's going to be our player controller. Double click that and open it up. Okay, I'm not going to make you sit there and watch me write out the code. I'm just going to do a quick jump cut, and then I'm going to explain the code afterwards. Okay, so here we've got the player controller script. We have 2 variables up here that are serialized, speed and range. We have a variable here, which is our y-axis throw. Our y throw is equal to our input.getAxis on the vertical. We then get the y offset by taking the y throw, timesing it by time.delta time, and then timesing it by our speed variable. After that, we get the raw y position from the transform, from our paddle's transform, and add the offset to it. We then create a clamped Y position using mathf.clamp. This will prevent the paddle from going too high up or too low down. We have our raw Y position, which is put in here, followed by our range. So minus range is -6 and range is 6. The final thing we do is we take our paddle's transform and we update it so that it moves. Right, let's make sure that this works. Now if all is right, it should move up and down. Yep, oh, it's moving a bit far though, a bit fast too. If that's 4. So now you can see the beauty of serialized fields. If I change that to 3, you can now see that we are locked to the Y on 3 positive and 3 negative. The speed could use a bit of work too, because I think that's a bit too far. In fact, I think the camera needs changed a little bit, so I'm just going to change the camera. Okay, with the camera changed a bit, is that nicer? Yeah, that's nicer. I don't even think I have to change the settings for that. Cool, cool, cool. Now we're going to create the ball script to make it move left and right across the screen. So, create new C# script. I'm going to call this ball. Here we have our ball script. We have a variable here for speed, which is how fast the ball is going to be going. And we have a rigid body 2D, which we need to add to the ball in a moment. The first thing we do in start is we get the rigid body and store it in RB. We set the velocity of RB to vector2 right times speed, which makes it so it goes to the right at whatever speed. On collision enter 2D, so we're going to need to put some colliders onto our paddles. We're using name references, which is not fantastic, but it works. For such a simple small game, it'll be fine. Col.game object name equals paddle left. It's going to get the direction to go in the right on the x-axis, whereas if it hits paddle right, it's going to go to the left by -1. This should all work. We're just going to quickly jump back over to Unity and give our ball and paddles the things it need. We're going to give our ball a rigid body 2D. We're going to turn that mass to 0. We're going to set collision detection to continuous. And then on the paddle left, we're going to put a box collider 2D. We're also going to put one on the paddle right. This is all well and good, but I don't think this is going to work. Ah, yes, the ball is using gravity. That's not what we want. We don't want the ball using gravity. Ball does not move because I haven't put the script on it yet. Now maybe? Yep, it went. It certainly went. I think I need to add a box collider to this as well. Turn the speed down to like 15 and let's see how that is. See if that works. Okay, okay. It hits paddle right and it just sits there. Cool, 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 cool. That is progress. Ah, okay. So I noticed the problem. This is the problem with string referencing things. So I spelled paddle EL here, and for some reason spelled it LE here. My mistake. We're using name references, which is not fantastic, but it works. For such a simple, small game, it'll be fine. That fixed, now maybe it will work. Yep, and we got the ball bouncing back and forth. This is nice. This is nice. So the next job we need to do is make it so the ball will actually bounce up or down depending on where on the paddle it hits. All well and good having the ball bounce back and forth, but that's not exactly a fun game. I've made some changes to the ball script. As you can see, I've created this method here called hit factor, which takes the ball position, the paddle position, and the paddle height. It takes the ball position on the Y minus the paddle position on the Y and divides that by the paddle height, and this essentially returns which direction it needs to go when it hits the paddle depending on where it hits it. Over in our collision enter 2D script, we have made some slight changes. We have this new variable called Y. Using our method, we are returning Y, which is the direction on the Y it's going. Instead of having 1 on the X, 0 on the Y, we are now having 1 on the X and our new Y variable here. And then we just plug that through as normal. So we save that. Hopefully, when we hit the ball, it should bounce. Oh, that's already bouncing up in a funny way. And it's off the map because we haven't got any boundary up there. Cool. The next thing I'm going to do is I'm going to add a boundary to the top and bottom. Before I go any further, I'm also just going to quickly clean up down here. So now we have a boundary at the top and bottom, so the ball can't go flying out. But unfortunately, when it hits that, it just kind of skirts along it until it goes off the map anyway. So to fix that, we need to create a 2D physics material. And we're going to assign that in our rigid body. Now, I think we want more of this. Oops. Okay, I just let the ball off. So it turns out that 1 was the best number to use for bounciness. Right, so with that done, we now have our ball bouncing up and down off the walls. We're going to quickly do the AI. Now this isn't going to be anything fancy. We're going to jump into our scripts, create C# script. We're going to call this AI and magic up some code. So this is our AI script. We have the 2 variables up here, speed and range, which are the same ones we are using in our player controller. We are also going to be tracking the ball and its position, so we're going to be storing that here. And vector3 move is going to store how much we need to move. So in the very first thing we're doing in the start method is we're finding the object ball, and we are getting its component. So this is so we know the position of the ball. This is only going to work because we have the one ball on the field. In update, we're going to follow the ball. The follow ball method is calculating the distance between the ball and the transform of the paddle, which is where the AI is. If this distance is more than 0, then it knows it needs to move up on the y-axis. If this distance is less than 0, it knows it needs to move down on the y-axis. It does this by taking speed or minus speed and timesing it by whichever comes out lower, the distance or 1.0f. This will basically make it so that the speed of the paddle changes depending on how far the ball is away from it. We then finally do the same thing we did for our paddle to clamp it in a range and pass that through to the transform.local position. What I'm hoping the paddle will do is follow the ball and hit it back to me. We had movement there, and it is moving quite nicely. It's got some speed there. I'm going to have to tweak this a little bit. Okay, fantastic, wonderful. The next thing to do is just make it so the ball increases in speed whenever it hits a paddle. That's really simple. I'm just going to quickly write that out. Okay, so all I've done is add this speed increase variable here, and then in both of these sections here, when the ball gets hit by a paddle, it will then increase the speed by speed increase. So let's just double check that worked. Did I save that? Yeah. Let's double check this will work. If I up the speed, and you'll be able to see it definitely pick up speed quickly. So I've upped it to 10.2. Yep, there you go. It hits the paddle. Boom, 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 boom. It's off the map. Gone. Easy. Nice. Done. I'm going to bring that back down to like 0.5 and I'll tweak that a little bit later. Okay, so now we want a scoreboard. So we're going to add some UI. We're going to be using TextMesh Pro. If you do not have TextMesh Pro, you can go to Windows Package Manager and find it in the Unity registry. So we've got our UI elements, our two numbers up here. I'm going to quickly go get a font for them to make them look more appropriate. Downloaded this font from dafont.com. It's 100% free. I think it makes it look a lot nicer. What I'm going to do is I'm going to create two collision boxes behind the paddles, that when the ball goes into the collision box, it will then reset and give whichever side a point. We've made these colliders on the left and right. The next thing we're going to do is create a script that's going to control our scoreboard. Open this up and make some code appear. Here's our scoreboard script. We have a left scoreboard and right scoreboard TextMesh Pro text, which we're storing using serialized fields. Then we've got the player 1 and player 2 score. We also have this public method that ball knows about. When this is called, it will know which collider has hit it, which game object. If it hits the left, player 2 score goes up and it updates the scoreboard. The right goal, player 1 score goes up and it updates the right scoreboard. Now if we jump back over to ball, we can see what I've done here. I've added an original speed variable, a spawn point variable, and a scoreboard variable. This scoreboard we're going to put in a minute. That's just going to be a simple hookup. And the spawn point is going to be where the ball respawns when it gets off the map. Then down in our onCollision enter 2D, we have two new if statements. One for if we collide with the left goal or if we collide with the right goal. We respawn the ball and then we set the speed to the original speed, sending it off with the velocity to the right like it was at the start of the game. And then we call on our scoreboard and call that method we wrote, passing through the collision.gameObject.name, and it does the same thing we're doing here, as I explained before. Let's test this out quickly. The ball should go off the edge and right should get a point. Okay, yep, that's the wrong way around. Okay, that ball is spinning like crazy. Like a shuriken. I'm going to quickly make that so it can't rotate. Yeah, I'm going to freeze the rotation. There we go. That should fix the ball spinning problem. I'm going to flip the scoreboards over. Down here in the scoreboard, we have the left score and the right score hooked up. And then over in the ball, we have the scoreboard hooked up here. Okay, and try again. Nice. That works. Okay, so the next thing I'm going to do is I'm going to add a second player. So I'm going to hook up some controls for a second player to actually play the game. Okay, so after a lot of tinkering, because I didn't expect it to be as hard as it was, we have switched over to the new input system. We have this input actions, which essentially allows you to add inputs either from keyboard controller. It pretty much makes adding inputs a lot easier than the old input system. So this is the solution that I came up with. We have a player controller object here, which is holding our player input. This takes in the player controls, which has our WS here and our arrow keys here, labeled under movement right paddle, movement left paddle. Go back to the player controller. In here, we are using invoke Unity events. We go to player. We have our left paddle callback context here, and our right paddle callback context here. This is calling two new scripts that are in our player controller script. So we're no longer using this because it's part of the old input system. But now we are using the new input system. We use this callback. So we're calling this method, which is then doing our Y throw and throwing it in here, doing what we did before. Although this time we're storing the transform for the left paddle and the right paddle. Then we just use all the same variables we used before, like Y throw, Y offset, etc. But we then use Y throw 2 on move right, which is the other side. I've doubled all my variables and I'm almost certain there's a more efficient way of writing this out. When I figure that out, this will be updated to reflect that. We've got a boolean here which is going to change depending if the player 2 is playing or not. If it is set to true, then the right player is able to play. The right paddle is able to be controlled by the arrow keys. Okay, well you have to take my word for it, but I am using WS for the left paddle and up and down arrow for the right paddle. Probably much better ways to do it, but it was a challenge I hadn't come across yet. With that set up, we only have 2 things left to do: the sounds and the menus. I haven't really got any sound developing software, so I'm going to use my voice. Beep, boop, beep. With that recorded, I'm going to cut out each of them, make them into MP3 files to then use in Unity. I've taken those 3 sounds, pitch shifted them to change their sound a little bit to make them a bit more, I don't know, gamey and less human-y. Next thing to do is have an audio controller which plays these sounds at the appropriate time. We're going to add an audio source to the ball because the ball is what's making most of the sounds in this game. We're going to jump back into our ball script and make a few more modifications. Now we have 3 variables up here for our sound effects: beep, boop and brr audio clips. We have our audio source audio. We get our audio source component in start. All of our if statements now have an audio.play one shot, which then plays the sound effect that we want to play. In case of the paddles, we play beep. In case of the goals, we play brr. In case we hit anything else, we play boop. As you can also see, we've changed these from if statements to else if statements, just so that if we hit anything else, we can play the boop sound effect. Now I'm just going to jump over into Unity and hopefully wire this up and it will work. I need to enable sounds from my desktop so you can hear this. Okay. Now let's see if this worked. Fantastic. All that's left to do now is the menu. I'm going to throw that together quickly. So I've made the main menu with 2 buttons, 1 player and 2 player. I've made this player selector, which is a singleton which holds a player 2 active, which has a script over here. What this script has is a true or false if the player 2 is active. On awake, this will find any other objects with this name and delete it. If you don't know how the awake, start and update methods work, essentially awake will always run before start, and start will always run before update, and there are a few in between it. I think I'll put a graphic somewhere. What this code is essentially doing is it's preventing any other player selectors from existing and not letting this player selector get destroyed. It uses tags, which is set up in Unity, and we have 2 public methods, one that sets player 2 active to false and one that sets player active to true. Then they both load scene 1, which is our game. Over on player controller, we are storing the player selector and then going to find it in start. Player selector already exists, it wasn't destroyed in the previous scene, so it should be fine. We then look at the player selector's player 2 active boolean, and if it's true, then we allow control of the other paddle. Otherwise, we turn on the AI. 1 player. Yep, the AI is moving. Beautiful. 2 player. Oh, wonderful. The last 2 things to do: make the background black and then make it so the game actually ends and takes you back to the menu. 2 very simple things to do, so let's do it. Okay, the end screen works. Fantastic. To make the end screen come up, all we did was I added an end screen canvas, which is hidden by default. It's got a button that returns to the menu. The script for that is a nice simple time.timescale 1f. It restores time because we're going to pause the game when the game ends and we want to restore it back to normal here, and load the main menu. In scoreboard, we're giving the scoreboard the canvas and the text inside the canvas, setting the text to whether the player 1 is the winner or player 2 is the winner, setting the end screen to enabled, and freezing the game by setting time.timescale equals 0. I have noticed one bug. When we go back to the main menu screen after finishing the game, the player selector isn't linked up with the buttons anymore. So I'm just going to quickly fix that. So make it that you can play it multiple times without it crashing. What I've done is I've given back the player controller the player 2 active boolean. And essentially we get the player 2 active boolean from the player selector, give it to our player 2 active in our player controller, and then destroy the player selector, because the player selector needs to be recreated in order for the buttons to link up with it correctly on the main menu. And then over in player selector, that's where we're doing the time.timescale when we select either one player or two player. And with that, Pong is finished, I think. And with that, Pong is finished. This version of Pong you've just watched me recreate, I'm going to upload to GitHub, and you can download it for free and do whatever you want with it. I would recommend taking it, adding features, making my code more efficient, just doing whatever you want with it. For the final part of this video, I'm going to be adding some features to Pong, but I'm going to jump cut to when they're already added and show you what I've done. Okay, here's Pong with some features added to it. I decided to add power-ups and a particle effect to when a goal is scored. I also recorded a new sound when a power-up gets picked up. I added this settings menu that lets you turn the audio on or off, and it also lets you turn on or off the different power-ups, which we have here. The power-ups themselves, I created their sprites in Libra Sprite. I created each sprite to kind of give an indication of what it will do when you actually pick it up. We have the back walls, which gives us back walls at the back of both Pongs. We have slow, which slows down the game. Slow is meant to be a snail. I think it actually came out quite nicely. We have speed up, which speeds up the game, and we have ball split, which causes another ball to spawn. Unfortunately, because of the way the AI is programmed, he still only follows the one ball. I've got the power-ups on a timer that will cause them to spawn. I also added when you press escape, you get a nice pause menu, you can quit back to here. I won't go into detail, I'll just give a quick overview of what I did. I used this option selector to carry over what power-ups are active in the game through the settings menu. We have a power-up controller which holds a bunch of transforms. These are all spawn points for the power-ups. We have a power-ups prefab which is spawned by the power controller, and that prefab is given this script. When the power-up spawns, a random power type enum is chosen. Then it assigns the correct sprite to the power-up. When the power-up's trigger gets entered, depending on what the power-up is, it does different things. Fast and slow power-ups, which have a timer on them, is handled up in update. The power-up timer is not active unless either fast or slow power-up have been picked up, and the back walls have their own script that control their timers. The last thing to do is to build it for WebGL and upload it to itch.io. And now that the game's uploaded to itch.io, you can go play it using the link in the description. If you've watched this long video all the way up to this part, thank you. I'm planning to put out more game dev content, probably not as long as this though. The next video I want to make is how to make a grid-based movement system like that in XCOM. And if you're not aware, I've been taking part in a March Blender challenge. It's a self-imposed challenge where I create a model in Blender every single day under the theme of Medieval Tavern. At the start of April, I plan to take all those models I've made, put them together and make a video about those models. So if you want to see some of those Blender models, go check the shorts on my channel. And if you enjoyed this content, I would ask you to subscribe. Thank you for watching the video. I hope you have a nice day.